Hello and welcome back. Let's do some math. We're on notes for multiplication property of exponents. The learning target of this video is I can use properties of exponents to simplify expressions involving multiplications. So first off, we need to talk about the core idea of what an exponent is. So the core idea is that an exponents are shorthand for repeated multiplication. So that's an important thing for us to remember when we're talking about exponents, that it is repeated multiplication. Another thing we need to talk about is an exponent itself and the different terminology that goes along with it. So this is what an exponent might look like to us. This little n is called the exponent. It's a subscript, it's smaller, and it is up to the right-hand corner of a number. The a would be the base number, and this whole thing together is called a power. These are just a couple different terms that we might use when we are talking about exponents, and they're important for us to look at. So we're going to talk about a couple different properties of exponents and how we might be able to add them together to simplify an equation. So first, we need to talk about what an exponent is actually doing, because that will help us understand how we can change those or add them or subtract them when we are doing multiplication problems. So when we are looking at 2 to the third, this is the same as 2 times 2 times 2. So we have 3 2's in there, and they give us 8. So it's the expanded multiplication form of 2 times 2. Another thing that we need to understand is that negative 2 squared versus parentheses negative 2 with the squared outside of the parentheses are different. They do not give us the same solution because only one of them are we squaring that negative, because in the first example, when the negative is outside, it's not connected to that 2, so we do not actually multiply the negative twice, while when the negative is inside the parentheses and the exponent is on the outside of the parentheses, it's indicating that we are multiplying that negative 2 times. So there's a couple different rules over here. We can talk about these as product quotient rules. So they are the same for products are what we call the sums of multiplications, and quotients are what we call the answer to a division problem. So when we're talking about multiplication, if they have the same base, that's the big part of this, they need to have the same base, and this is where our terminology over here comes into play. So when we have 2 to the fourth times 2 to the second, these both have 2 as their base. So we can look at those in their expanded form: 2 times 2 times 2 times 2 times 2 times 2. So when we're looking at that, we can just count the number of 2's. So we see 1, 2, 3, 4, 5, 6. So we know it's 2 to the 6. So a simpler way of doing this is we can add the exponents together. So we can do 2 to the fourth plus 2, or 2 to the sixth. So that's only when they are the same base. The same can be said for division, and we will talk about that when we are doing division properties of exponents. But the big thing that we need to think about is they need to have the same base. That's step number 1. Then step number 2 is when they're multiplied, we add the exponents, and then we get the answer. So in these examples below, I don't have any powers because it didn't print correctly. So we are going to add those in there. So let's do the first one together. So when we are looking at this first one, we can see already that it did not print correctly because this was supposed to say 4 to the 5th times 4 to the 9th. And I'm pretty sure on your paper it might look like that. It just didn't translate when I was putting it on here. So when we are multiplying them and the bases are the same, those 4s are the same, we can simply add the exponents. So 4, 5 plus 9 is equal to 4 to the 14th. So that's our answer. Walk away. Again, it did not print correctly here, and this one might look hopefully better on your paper, but this one was supposed to be 3 to the 9th in parentheses with a 2. We didn't specifically talk about this previously, but see how these are multiplied together, and when we have parentheses, we are distributing in. That distributing property carries over to exponents. We distribute this exponent in, and we actually now have a multiplication problem. So it is 3 to the 9th times 2, which is the same as 3 to the 18th. We can look at this in the expanded form to really help us understand that, because this could be 3 times 3 times 3 times 3 times 3. We need 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we did that 2 times now. So then we need another one of those. We need 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that is the expanded version. And when we are looking at it this way, we can understand why there are 18 and why we distribute that 9 inwards. Okay, let's do a couple more problems here. Again, my paper did not print correctly, so I'm going to rewrite it for you here. 2 to the 2nd times 2 to the 5th times 2 to the 8th. Again, this is a simple multiplication where all of them have the same base, so we're simply adding those exponents together. 2 to the 2nd plus 5 plus 8 becomes 2 to the 15th. Box it and walk away. This is just an examples of how to simplify those exponents. We're not actually doing the exponents together. Okay, let's take it up a notch here. We'll go down here, and I'm going to slightly change number 5 just to make it a little bit more challenging. If I have 6 to the 5th, and then I am timesing that by 6 to the negative 5th. Now we have a negative exponent, and a negative exponent, we treat it the same because a negative exponent can be understood as 1 over 6 to the 5, but when we convert it into a non-fraction form, it becomes a negative. So this is the same. We do 6, they both have a base of 6, and we do 5 minus 5 because we have a negative 5 up there. So this just becomes 6, which seems simple, and we can work through this multiplication because we can look at it as 6 times 6 times 6 times 6 times 6 times 6. We have, oh, sorry, I got a little carried away. I gave too many 6s there. Only 5 of them. And then because this is a negative 5, it would actually look like a division of 6 times 6 times 6 times 6 times 6. So that's why it ends up becoming 6 to the nothing, or 6 to the 0, which is the same as 1. Oops. 1. Because we get 6 to the 0, and anything raised to the power of 0 equals 1. hopefully this was helpful. We'll go over a couple more of these more in-depth problems in class. Please bring any questions that you might have.